Okay, picture this. Your inbox just overflowing, right? Endless photos on your phone, streams of video, sensor logs from, well, everything around us.
Yeah, it's overwhelming.
We are absolutely drowning in data. It's just raw, unorganized, sometimes chaotic. So how do we even begin to make sense of it all?
Mm-hmm.
How does that fire hose of raw data transform into something, useful, something intelligent, something that can actually help us make decisions or drive action?
That's really the fundamental challenge, isn't it? Moving from just this flood of symbols and signals to genuine understanding and meaningful
And
impacts.
that's the journey we're taking in this deep dive, guided by the sources you shared with us. We're going to unpack several big interconnected ideas.
Right.
We'll start with the basic levels of how we even think about information. That classic idea of data, information, knowledge, even wisdom.
And then we'll trace the sort of practical path data takes to actually become valuable,
Mhm.
walking through the stages from just collecting it all the way to, using it to change things in the real world.
Yeah, and then we'll dive into the cutting edge AI tech that's doing the heavy lifting, transforming that raw, messy, unstructured stuff like text and images.
Into something organized, something machines can actually understand.
Right.
And crucially, we'll explore how AI isn't just processing symbols, but starting to kind of understand relationships and context through something called embeddings.
Ah, embeddings. Okay.
And we'll also look at how we structure complex information logically using hierarchical classification.
And underpinning all of this is that deeper principle of knowledge representation, how AI systems actually build an internal model of the world to, well, enable reasoning.
Finally, we'll bring it all together, see how these concepts show up in autonomous agentic AI systems, and ground it in some recent trends we're seeing out there right now.
So our mission in this deep dive is really to pull out the most important nuggets from these sources, give you that shortcut to understanding these core concepts and what they mean for, navigating and leveraging information in this increasingly AI-driven world. Okay, let's unpack this.
Let's do it. Maybe start with that foundational model. The DIKW hierarchy, data, information, knowledge, wisdom. It's often used in information science.
Right.
It's a way of thinking about how raw symbols, basically, evolve into something you can actually use and understand deeply. People like Milan Zeleny and Russell Ackoff were key in defining these layers.
Right. So at the absolute bottom, you have data. The sources describe this as just symbols or signs. It's explicitly called out as being of no use until
Yeah.
in a usable form.
Yeah, no nothing.
No, nothing, exactly. Just signs like isolated pixels in an image or individual words on a page without any context, just raw, inert stuff.
Precisely, it's passive. Now, step up to information. This is where data gets endowed with meaning and purpose, becomes useful.
Okay.
Ackoff's classic definition says information is inferred from data by answering those basic questions. Who, what, where, when, how many.
Right.
The core idea is that information makes data useful for decisions or actions. One source put it really powerfully, data that changes us.
Oh, I like that. Data that changes us.
Zeleny saw information as what to have or to possess, defining the why is. And he makes an interesting point that knowledge, when it's made explicit, when it's captured symbolically, actually becomes information.
Huh.
Now-
Okay, that's an interesting twist. So information is data with context and relevance, designed to be shared, understood by others. It answers specific questions.
Exactly.
Now, knowledge, the sources note this is a vague word, often defined with reference to information.
It is a bit fuzzy.
Yeah, it's seen as subjective, not universal. It's information that's been processed, organized, structured, applied, put into action.
Zeleny's take here is quite strong. All knowledge is tacit. It's
Yeah.
inside us until it's externalized as information.
So knowledge is that internal framework, that understanding of patterns, connections, the how-to. Information is the external shareable form of that internal know-how.
You got it. And then at the top, often discussed less in the specific model from the sources, is wisdom. This relates more to applying knowledge, making judgments, seeing the long-term implications, what to do, why do. One definition simply calls it non-material.
So judgment, insight built over time, applying knowledge in complex situations.
Got it. It's worth noting, like you said, the sources acknowledge these definitions can be debated. It's a model, right? Not rigid law.
Absolutely.
But the core idea of these distinct levels, moving up, is really useful for understanding how value gets added as you move beyond just raw data.
Definitely. And moving from that conceptual hierarchy, let's look at a more practical framework. The data value chain.
Right.
This shows how data actually gains value in the real world. It's often compared to like Porter's business value chain,
Oh.
showing how raw data moves through stages to become impactful.
Or the data is the new oil idea comes in here, doesn't it?
It does. Raw, it's not that useful, refined, it powers everything. The central idea is transforming that raw, low-value data into actionable information and ultimately high-value impact.
And this chain has, what, 4 main stages? It starts with collection. Yep.
Collection includes identify, collect, and process.
So figuring out what you need, grabbing it, surveys, admin data, sensors, whatever, and then cleaning it, coding it, storing it. Quality standards are mentioned as key here.
Super important from the start. Yeah, like the IMF DQAF. A great example of the sources give is UNICEF collecting data on time spent on household chores by boys versus girls.
Ah,
This wasn't just random collection. They identified a need to understand disparities in unpaid labor, then specifically revised survey methods to collect that precise data.
gotcha. Purposeful collection. Then comes publication. Analyze, release, disseminate.
Right. Making the data accessible. You analyze it, publish it with metadata, share it widely. The value jumps up significantly here because now others can see and understand it.
Okay.
The high-resolution mapping example is perfect. Taking raw survey data on, say, contraceptive use in Africa, analyzing it to create visual maps, a higher value form, and then releasing it with detailed instructions.
So it's about thoughtful analysis, open formats, standards. Exactly. Then the next stage is uptake. Connect, incentivize, influence.
This sounds crucial, getting people to actually use the data.
It really is. It's about connecting potential users to the data, giving them reasons to use it. Maybe it's an order, a budget line, training, and influencing them to value evidence-based decisions.
And trust is key here, right? Trust in the quality.
Absolutely fundamental, built through transparency. If people don't trust the data, they just won't use it. Simple as that.
Makes sense.
The UNECA's Gender Statistics Toolkit is a prime example of driving uptake. It educates both the data producers and the potential users, building capacity and literacy needed to actually engage with gender stats. It's bridging that gap.
Okay, building the bridge. And finally, you get to impact. Use, change, reuse.
This is the payoff. Using the data for decisions, seeing positive changes and outcomes, and ideally reusing that data, maybe combining it with other sources.
And positive results, feedback, building more trust.
Exactly. It creates a positive cycle. The sources emphasize data should be open at this stage to maximize reuse, and we see powerful examples of impact.
Like the Burundi example.
Yeah, using sex disaggregated financial data showed women were excluded, which helped design a new law directly increasing their access to credit. That's direct impact.
Yeah.
Or in Bangladesh, analyzing maternal death data through the MPDR program led to action plans that actually reduced maternal and infant deaths, leading the program to expand nationally. That's data saving lives.
So the big takeaway from the value chain is, well, data doesn't just magically become valuable when you collect it.
Nope, that build it and they will come idea obsolete.
Right. Value is created through deliberate steps. Processing, publishing, promoting uptake, ensuring it drives real impact. And there are roadblocks everywhere: resources, quality, trust, silos.
And what's really fascinating is how achieving that impact is, it's a collaborative process. It relies on building trust all the way through the chain.
Okay, so that's the journey. Now, how does technology, specifically AI, fit into this? How does it help move data up the chain, up the DIKW pyramid? Because so much data today is just messy. Unstructured text, images, video.
Exactly. This unstructured data holds immense potential value, but you can't easily run analytics or automate decisions based on, a raw image or a block of text. You need structured data.
Organized data, predefined models, so you can actually use it for analysis and scaling up decisions.
Precisely. And AI is the primary engine for this transformation. The sources detail the key AI technologies doing this magic. First, for text, it's natural language processing, NLP.
Okay, NLP, how does that work?
NLP lets computers read and understand human language. It uses techniques to break down text tokenization, tagging parts of speech, identify key things like names, dates, organizations, that's NER, understand relationships, even gauge sentiment.
So it turns raw documents into structured data sets.
Essentially, yes. Think analyzing thousands of customer emails to spot common complaints, or automatically pulling client names and amounts from contracts. Tools like Spacey, Google Cloud Natural Language API are big here.
Got it. Then for images and video.
That's computer vision. It uses deep learning, especially convolutional neural networks or CNNs, to process visual data, basically teaching computers to see.
What can it do?
Identify objects, recognize faces, extract features. Applications range from categorizing millions of product photos online to using OCR optical character recognition to pull text out of scanned documents or images. Amazon Recognition, OpenCV are examples.
And for audio, like call recordings.
That's speech to text. AI models transcribe spoken words into written text, making audio searchable and analyzable. Super useful for call center analysis, voice assistants, things like that. DeepGram, Google Speech to Text are players there.
And AI can pull key info out of documents too, right? Metadata.
Yeah, metadata extraction often combines NLP and OCR. It automatically identifies and organizes key details, dates, authors, maybe summaries from documents. Essential for managing large archives or automating workflows around invoices or medical records, AWS Textract is a tool built for this.
So the big picture here is that AI is the essential tool. It bridges the gap between that overwhelming flood of unstructured data and the need for structured information to actually power advanced analytics and automated processes. It takes the chaos and gives it structure.
Right. But just having structure isn't enough for deep understanding.
Right.
Once data is structured, AI needs a way to grasp the subtle relationships, the context within that data, not just what it is, but how it relates to other things.
Okay.
And this is where embeddings come in, a really critical concept for how AI processes complex, real-world information.
Embedding still sounds a bit technical. Can you break it down?
Okay, think about movies again. You could list features. Sci-fi, yes, no. Comedy, yes, no. Actor A, yes, no. Huge list, very sparse. It doesn't tell you if Star Wars is like Star Trek. Embeddings do something different. They represent each movie or word or product or whatever as a point, a vector, in a multidimensional space. Usually fewer dimensions than the raw features, but dense with meaning.
A point in space.
Yeah. And the key is, things that are similar in meaning or concept end up closer together in this space. So, Star Wars and Star Trek might be near each other. A rom-com and a sci-fi epic would be far apart. The distances and directions mean something about the relationships.
Ah, so it's capturing the relationships and meaning, not just features in a mathematical way.
Exactly. Embeddings are those numerical representations, those vectors, that let ML models understand complex domains by capturing inherent properties and relationships. They compress data into fewer meaningful dimensions.
Why is that so important for AI?
Well, several reasons. It turns messy, real-world data into a format. ML models love dense numerical vectors. It captures nuances that simple flags miss. This improves data quality for training big models like LLMs. It enables killer apps like finding similar images, recommending products you might actually like, understanding the context of words. It's fundamental to modern AI.
And the sources mention specific models. Word2Vec, BERT.
Yeah, those are famous examples, especially for text. Word2Vec learned embeddings for words based on their neighbors. It can capture analogies like kingman plus woman equals queen, just using the vectors.
Whoa.
BERT is more advanced, and it looks at the whole sentence, so the embedding for bank changes depending on whether you're talking about a river bank or a financial bank. It gets context.
Okay, here's where it gets really interesting. Embeddings are basically how AI starts to translate complex human stuff, meaning context, similarity into math it can work with. It's how it moves beyond just seeing symbols to seeing connections.
Precisely. It's a huge leap in capability.
So we've structured the data. AI can understand relationships via embeddings. But with huge amounts of data, even structured stuff needs organization, right? Which brings us to hierarchical classification.
You got it. Even with embeddings, you need logical structure sometimes.
That's like categories and subcategories, like a tree.
Exactly. Sorting elements into progressively more specific levels based on parent-child relationships. Think biology. Animal, mammal dog, golden retriever. General at the top, specific at the bottom.
Why is this so vital for AI? Just neatness.
Oh, much more than neatness. It's crucial for tasks where you need a structured output or where the relationships matter for the decision. Think medical diagnosis, product catalogs, document libraries. It influences how algorithms like decision trees work and helps models make more accurate decisions by considering that logical structure.
So it helps the AI be more precise and efficient in its classification.
Yes, and the output is often more interpretable for humans too. Instead of just saying it's a vehicle, it can say vehicle, car, sedan, Honda Civic.
Makes sense. And the sources mentioned real-world benefits.
Yeah, the Sport Web Portal example was great. By using hierarchical classification for their content, they got better accuracy in tagging. Readers spent significantly more time on the site because navigation made sense.
Oh, wow.
And journalists spent much less time manually tagging articles. Big wins in efficiency and user experience.
That really shows the value. So what does this all mean? It means organizing data logically, hierarchically, isn't just admin. It's fundamental to making AI systems smarter, more efficient, and their outputs more meaningful.
Which leads us to an even deeper level. How do AI systems actually represent knowledge to enable reasoning? This is the domain of knowledge representation, or KR.
KR. Okay, so this is more than just data structures.
Much more. It's about how the AI system represents its understanding of the world, specifically in a way that allows it to reason effectively.
The sources laid out some key roles for KR. It's a surrogate for reality, meaning it represents something real, but it's always a simplification.
Right, an abstraction. But the really critical part the sources emphasize is what they call ontological commitments.
Ontological commitments. That sounds heavy. What does it mean?
It means the choice of how you represent knowledge in an AI system fundamentally embeds a specific view of the world. It dictates what kinds of things exist for the AI, what concepts are important, how they relate.
Okay, give me an example.
Think about building an AI for medical diagnosis. You could use MYCIN's approach, basically, a big set of if-then rules. If symptom X and D test Y, then maybe disease Z.
Okay, rules.
Or you could use something like Internist's approach, using frames which structure knowledge around diseases, their typical findings, symptoms, etc., in a more organized, concept-centric way.
So different ways to organize the medical facts.
Exactly. And the sources argue these aren't just technical choices. Choosing rules versus frames means the AI sees the medical world differently. One sees it as chains of logic, the other as interconnected concepts. The KR choice is a choice about the fundamental reality the system operates within.
Wow. Okay, so the KR shapes the AI's entire perspective and how it can even think about problems.
You got it. It also embeds, as the sources say, a fragmentary theory of intelligent reasoning. The KR reflects an idea of what counts as smart thinking in that context. Is it strict logical deduction? Or is it more like how a human expert might jump to conclusions based on patterns, like frames might support?
Different models of intelligence.
Right. And KR also has to be a medium for efficient computation. It has to organize info so the AI can reason quickly, and a medium for expression, giving a language to talk about the world.
And the big consequence here is that representation and reasoning are totally tangled up.
Inseparable. Building an intelligent AI isn't just about knowing what inferences are logically possible, like A implies A and A and A, but which inferences are useful or intelligent for the task. The KR guides that.
This connects directly to agentic AI, right?
Yeah.
The reasoning engines must rely on these underlying KRs to figure out how to process info and make decisions.
Absolutely. Which brings us neatly to the culmination of all this. Agentic AI.
The goal-oriented autonomous systems, making decisions, taking actions, without us holding their hand the whole time.
Exactly. And they simply couldn't exist without these foundations we've discussed. They need massive amounts of data.
Which they have to process from raw forms, structure it using NLP, computer vision.
Understand the complex relationships using embeddings.
Organize that understanding logically with classification.
And then reason and decide based on those underlying knowledge representations that define their worldview and their reasoning style.
Right. The sources describe that agentic loop. Sense, get data query, retrieve, pull relevant info, maybe from vector databases using embeddings, reason, use LLMs, other AI models guided by the KR Act, generate insight, do something.
That loop integrates everything. Data, information, knowledge processing, representation, reasoning, action.
It's like they're building their own internal DIKW pyramid, constantly cycling through it. The sources get a bit philosophical here.
Yeah, comparing agentic AI unifying data to string theory unifying physics.
Or referencing Paulo Coelho about the universe conspiring to help you achieve goals, suggesting AI needs multidimensional thinking.
And bringing this right down to earth, that McKinsey survey mentioned shows generative AI, a key enabler for agentic AI, had a massive breakout in 2023.
Huge adoption, especially by companies already good at AI.
And they expect massive disruption, especially in knowledge work. The trends are clear. Fast adoption, focus on business value, new products, services, changing talent needs. Hello, prompt engineers, and big workforce shifts coming, reskilling needed.
But the survey also flags risks. Inaccuracy is the big one for Gen AI.
Right. And while most companies say they're tackling it, a chunk aren't. And as these systems get more autonomous, managing risks like inaccuracy, bias, ethical concerns becomes absolutely critical. Think about the UNESCO points on ethics here, too.
Definitely. So this ties all the theory data, knowledge, representation to the very real, very fast deployment of these potentially autonomous AI agents.
Yeah, it's happening now.
So we've really covered a lot. We journeyed from just raw data through its transformation into structured, understood insights, how AI represents and reasons with this using embeddings, classification, knowledge representation.
And how it all comes together in these agentic AI systems, right in the context of this rapid real-world adoption and its associated challenges.
Understanding these layers, from data chaos to potentially intelligent action, and the AI mechanics underneath feels absolutely essential for anyone trying to navigate this AI-powered world. It's seeing the whole pipeline.
Seeing the forest and the trees, the data and the potential wisdom, maybe.
Exactly. And, as we think about these agentic AI systems setting their own goals, acting autonomously based on data and reasoning, and knowing, as we discussed, that their knowledge representation embeds a specific view of the world, a specific theory of intelligent reasoning. It does raise a pretty provocative question, doesn't it? What happens when an AI's embedded worldview, or its programmed definition of intelligent action, starts to diverge significantly from our own human values or intentions, especially when it's operating out there on its own?
That's definitely something to mull over. Where does that autonomy lead if the underlying philosophy isn't aligned?
Exactly. A question for another time, perhaps, but
Yeah.
definitely one to keep in mind.